Yes. Okay, guys, just click the link and start working on the warm up. So this is just to review what we studied last time. Guys, you have to join the warm up. Just use this link. Join the warm up, and we have about 6-7 minutes. So this is just to review what we studied last time. All about area, volume. So this is all about area and volume. Okay, guys, we have 4 minutes. Okay, guys, today we are going to start a new unit, exponent and logarithms. So first we have exponents. We will talk about basic forms of exponential function. So just finish up the warm up. We have 2 minutes. So this lesson is relatively easier. So I'll take about not more than 1 hour, maybe 40 to 50 minutes. Then the remaining time, I'll give you time to work on the assignment 12.1 or any assignment you haven't completed so far. Remember 6.1 and 6.2 are open until today, 11:59. So I talked about it on Tuesday. So I already opened them. So most of you already finished them, but some of you didn't finish. So you can still use the time to complete those assignments too. Okay, guys, it is time. I'll start our lesson for today. So it's 6:10 now. So just practice on the warm up. That is basically what we studied the last 2 weeks. So today we are going to start a new topic. It is all about exponential functions and exponential expressions. Do you have question, Jasmine? I think Jasmine is right. Which one are you talking about? Jasmine, I don't understand. 32821. So if it is open until 28, you're good until the weekend. So that's the good news. But try to complete it today if you can. Yeah, you have to do it today. It was due to the 21st, but there was some, my computer. If when I work with, there are two computers I use. One of them is in East time, so I have to fix that. And I sometimes forget and I use that computer, and that's why the time changes. Sometimes it uses East time, sometimes it is Pacific time. So I have to check again and again. So now, from now on, all the assignments are due at 11:59. So on the due date. No. So only the exam. So I talked about this when we begin. There are 3 mid exams. So we took exam 2, and we have final exam. So out of those exams, one of the lowest score will be dropped and replaced by the final exam if you do well on the final exam. That's the quizzes and the homework assignments are 30%. So I don't really worry about them to change and drop. But for the final exam, if you do well on the final exam, it can replace one of the exams. If you miss them, one, or if you fail them. You're welcome. Okay, now let's start our lesson for today. So today we have 4 objectives. Okay. Our lesson is exponential functions, and we have 4 basic objectives. So the first one is recognize or identify exponential functions. So we will see the form of exponential function. And if you are given different functions, we are going to identify if a given function is exponential or not. Then next we will identify the base of exponential function, and I will explain what base is. Okay? So the base of exponential function. And next we evaluate exponential function. And if you know how to evaluate function, you can graph them. So the fourth and the last objective will be graphing exponential function. Simple. We are not going to go very complex to see very complex function, but we are going to look at relatively simple functions. Okay, so this is just introduction. Okay, so the lesson is not hard; it's simple. I am planning to give you time even to complete the assignment within our scheduled time. So the assignment may not take more than 10 to 20 minutes. Okay. Now let's start with the first objective. So recognizing exponential function. That comes from the definition of exponential function. You see here, I have highlighted the function in yellow. An exponential function is a function in the form y equals a times b the power of x. A times b the power of x, where b should be greater than 0. So these are the conditions. The first thing, b should be greater than 0. B cannot be negative. The next condition, b should be different from 1. If it is 1, it's not exponential function, it will be linear function. B should be different from 1. This 1 will be like a straight line, but exponential functions are curved. So two conditions. 1, b has to be positive. 2, b has to be different from 1. Now, b is the base of the exponential function. So b is called the base. So b is base, and a is called the initial value. Initial value, or at start when x equals 0, you have a. When x equals 0, you have a. So that's why it's called initial value. And x is in the variable. So that's the one of the way we identify exponential function. X should be in the variable. Sorry, in the exponent. So the variable x is in the exponent. So x is in the exponent. Right? So if you have these three conditions met, that means b should be greater than 0 or should be different from 1, and x should be in the exponent. That kind of equations are called exponential equations or exponential function. Now we are going to identify the following functions. If they are exponential function, and we are going to determine the base. Okay. Now question number 1 says y equals 3 to the power of x. So if you see the base is 3, x is the exponent, and b is positive. So yes, this is exponential function, and the base b is 3. In this case, a is 1, so the initial value is 1. Now, what about number 2? Is it exponential function or not? Number 2, yes or no? Type on the chart. Look at the conditions. No, you go, why not? Oh, are you looking at number 2 is to the right, not below. Lower than 0. Okay. Okay. So if you see this expression and compare it to y equals a, b the power of x, what do you think is b? What is b? What is a? Just look at the equation and the general form of the equation, which is a times b the power of x. So what is the base now? Yeah, 2.7, which is greater than 0. So b is 2.7, which is greater than 2. That means it is exponential function. Yes, it is exponential function. Okay, number 3. Yes or no? Number 3. Number 3 says x squared. Is it exponential function or not? Yeah, that's not exponential function because the variable is not in the exponent. So this is a polynomial function, specifically quadratic function. So this is not exponential function because x is not in the exponent. So x is the base. X cannot be the base. Okay, number 4, yes or no? Again, what is the base and is it exponential function? So what is the base? We can say yes. The base is pi. Yeah. So b is pi, which is a number greater than 0, 3.14. Now, number 5 and 6. Before I ask you the yes or no question, what is the difference between the two? Anyone can explain the difference between the two? Or tell me the base for each one of them. So what is the base for this one? B. What is the base for this one? For number 5, what is the base? -4, okay. Okay. What about number 6? Doesn't have base. -4 again. So both of them have -4. Are you saying the two equations are the same? Are they the same? But both of them have base. Now, this is the difference. If the negative is outside of the exponent, in number 5, the negative is outside the exponent. Because if you follow PEMDAS, so the negative is subtraction based, guys. So you do exponent first, then subtraction. So for that, this expression is y equals -1 times 4 to the power 5. So a is -1, b is 4. A is -1, B is 4. So if there is no parenthesis, B is positive, and there's -1 outside. So the number -4, that number is not -4. So there's negative of x for the power back. So B is 4, and this is exponential function. But this one is not exponential function because the base is -4. If it is inside parenthesis, it is included in the exponent. So this is not. Okay. So that's how you identify exponential function or differential exponential function. Any question on the first slide? You guys have question? Okay. Now let's go to the next. Now next we'll talk about exponential growth function and exponential exponential decay function. Okay, there are two types of exponential function depending on b, the value of b. So if b is greater than 1, b is greater than 1, the function will increase. The function will increase. So if b is greater than 1, the function will increase. Okay? So we call this kind of function a growth function. Let me show you a typical growth function. So it usually crosses at a, the initial value is a here, and it will go like this. So this is a growth function when b is greater than 1. Okay? Y equals is increasing function. Increase as x increases. Okay, so the function value increases as x increases. So that's why it's called growth function. So the way we identify a growth function is if b is greater than 1. Now the second function is called decay function, decreasing function. So this one is if b is between 0 and 1. So 0 less than b less than 1. So numbers between 0 and 1. If b is a number between 0 and 1, you have a decreasing function or a decay function. So this function decreases. So let me show you the graph. So again, it passed through A and it goes like this. You see here, it doesn't cross the x-axis. It just approaches the x-axis. And we call it a horizontal asymptote. Horizontal asymptote. So don't worry about it for now because this will be taught in advanced and higher level math. So you'll see asymptotes and graph in most probably 124 or above. Okay, so this function decreases. Y equals a b the power of x, decrease as x increases. Okay. Now b equals 1. Let me give you one example of growth and decay function. If you guys remember, the last year we've been talking about the rate of coronavirus infection. So we've been talking about rate of infection is going exponentially, or this is increasing exponentially. Like, for example, initially it was like this, smaller, and it would go up, 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 right? So in this region, b is greater than 1. So b is greater than 1. So it is increasing very fast. Then finally, when b becomes 1, it plateaus. So it becomes plateau, something like this. When b is closer to 1, okay? Then if b is less than 1, it will decrease. So you can see the curve for different states or for different countries. You see this kind of graph for the rate of infection of coronavirus. It follows exactly the same pattern of exponential function. So initially it will increase, then it will plateau when b is closer to 1, then it will decrease when b is less than 1, between 0 and 1. Okay, so just pay attention to any news outlet, and when you see the curve, you can see exponential function. So exponential functions are used to model real-world application, a lot of real-world application, like population growth or decay. For example, bacterial growth or bacterial decay. You can model it by using exponential growth or exponential decay function. So this example is exactly, I mean, very, very helpful. helpful to understand exponential growth. So it grows very fast. Initial was this small and then will go because it multiplies itself over and over. It grows very, very fast. Then also it will decay when the b value is less than 1. So you may heard about the rate of infection is if the rate of infection is greater than 1, like if it is 2, the authorities are very, very worried. They will shut down the cities and do a lot of measures because this curve will go when b is, let's say, 4, it will go like this very fast. If it is 6, it would go like this. So they are worried about the rate of infection. So you can see it from exponential models. Okay. So this is one of the examples. Now let's go to the next topic. The next topic we are going to identify if the given function is growth or decay. Okay. We are going to identify if the given function is growth or decay. So write down the problems. The functions. Then we are going to label them decay or growth. So b greater than 1 is growth. Growth. B between 0 less than b less than 1, we have decay. So determine whether the given functions are exponential growth or decay functions. If so, identify the base of the exponential function. So we are going to identify the base also. Okay, number 1, is it a growth or a decay function? Is it a growth or decay function? Yeah, this is a growth function because b is 3. So this is growth function because b is equal to 3, which is greater than 1. Okay, good. What about number 2? Growth or number 2 is to the right. Growth or decay? I want everyone to participate. Type on the chat. Yeah, it is growth because b is 7. Yes. So this is also growth. So b is 7. Inside the exponent, we have the base 7. Number 3. Number 3. Exactly. This is a decay function. Decay means decreasing function. So b is 0.6, which is a number between 0 and 1. 0.6 decimals, 0 point something is a number between 0 and 1. So this is a decay function. Number 4, growth or decay? Exactly. So this is growth because b is pi, which is 3.14, greater than 1. Okay, greater than 1. Number 5. Excellent, Diana. Excellent, Norma. Excellent, Abhi. Here you go. Excellent, guys. So this b is 1/4, which is a number between 0 and 1. So this is a decay function. Okay. Now the last one. What kind of function is this? You guys think it is a decay function? Okay. So now here's the thing. We said when we defined b cannot be negative. So here b is -2. So that's not exponential function. So this is not exponential function. Okay, so you have to pay attention to b. B cannot be negative. If b is negative, that's not exponential function. So neither decay nor growth function. Okay, so this is not exponential function. Okay, so did you guys understood how to find the base and how to identify exponential function? Can we move to the next topic? Okay, let's move to the next topic. Next, we'll see how to evaluate exponential function. I don't know if you guys have calculators with you, so we are going to use calculators, okay? Uh, so what you do is you substitute the given number. Evaluation is just substitute the given number, and you can use your calculator and type the numbers. If you don't have calculators, you can just Google on online and you can just type scientific calculator. And now this question says evaluate the exponential function at the given x value. So x is -2 and the function is 0.5 times 3 to the power of x. So f of -2 equals 0.5 times 3 to the power of negative. Just plug in -2 into the function. Now use your calculator and evaluate this function and type your answer on the chat. Anyone with answer? Type your answer. What is f of -2? If you don't know how to find this, let me know. That is not 18. So did you multiply? So that okay. Negative exponent, usually this is the same as 0.5 over 3 to the power. Because negative exponent goes to the denominator and becomes positive. If you guys remember properties of exponent. So it is 0.5 over 9. If you want to use properties of exponent. Yeah, so that we don't I think you just put 3 squared. That would be 9. Now use your calculator. You don't have to apply the rules. You just use your calculator and type 0.5 times 3 to the power of -2. So this number gives you 0.055555 continuous like that. So 0.05. So we can just round to 3 decimal places. Okay, so that's how you must evaluate exponent. Okay, now evaluate the second one, f of 2. Find f of 2. So example 2 says find f of 2. So it's -5, 0.5 to the power of x. Use your calculator, or if you know how to apply properties of exponent, you can use exponent. But it is very important if you use your calculator. Just plug in the numbers and it will give you the exponent. Excellent, Hugo. Yep, excellent, Norman. So we have f of 2 equals -5, 0.5 to the power of 2. So 0.5 to the power of 2 is 0.5 times 0.5. So just put that in your calculator and you will get f of 2 equals negative 1.25. Okay. Now, if you know how to evaluate, it's easy to graph. That's why we are learning how to evaluate exponential function. So evaluation is very, very important. So next we'll see how to graph exponential function. How to graph exponential function. So to graph exponential functions, you need 3 points, and you have to know. So usually we are considering basic functions. That means x equals y equals 0 be the horizontal asymptote. So it doesn't cross the x-axis. The kind of equations we are looking at, or the kind of functions we are looking at. So we have 2 examples here. Like graph the following function and check your result using your graphing utility. So in your MyMATLAB, when you go to MyMATLAB, you have graphing utility, or you can use calculator. Okay, graphing calculator in the online. So just to check your answer, not to work. So what you do is this is a function. Graph functions like this. You make a table x, y, and you need only 3 points. So usually we pick numbers around 0. So -1. Let's pick -1, 0, and 1. Okay. Now plug in -1 and find f of -1, f of 0, and f of 1. So what is 3 to the power of -1? Yeah, graphing is a little bit challenging for us. I understand that. But now, if you know how to evaluate, this one is easier. So if you know how to evaluate, all you have to do is plug in the numbers. So 3 to the power of -1, that's the function, which is 3 to the power of x. Just plug in -1 for x. That is not correct. So exponents are usually will not give you negative. They will give you always positive number. So if you have negative exponent, it becomes fraction. So 3 to the power of -1, negative exponent goes to the denominator and becomes positive. So it is 1/3. 3 to the power of 1. So 0.333 exactly. If you use your calculator, it will give you 0.333. So which is technically 1/3. Now at 0, plug in 0. Any number power of 0 is 1. Or just use your calculator. Plug in 0 and 3 to the power of 0 is 1. And 3 to the power of 1 is 3. So once you have these 3 points, it's just plot the points. That's all you have to do. So we know this is the growth function. It will increase from left to right. It will increase. We have 1, 2, 3, 4. Let's say we have 1, 2, 3, 4. 1. Okay, at -1 it's 1/3. So -1 is over here. 1/3 is close to 0. And at 0 it is 1. Oh, let me use different color. It's not visible. Let me use red. Let me see what I'm doing. And at 1 it is 3. So clearly this graph is going up like this. And remember, the x-axis is the horizontal axis. So it doesn't cross the x-axis. It will go like this. Just approach the x-axis. Okay. So this is exponential growth function. Growth function. You guys have any question on this one? redo the graphing. So on our quiz, we were unable to graph 1/3 or 1/2. Yeah, usually you don't. So if you know 2 points, usually it will give you the third point right away. So it has a graphing tool. It has a graphing tool. So if you input 0, 1, and 1, 3, 1 and 3, it will give you the third point. Okay. I checked that for some of you. For example, there was one question which says graph y equals negative 2x plus 5. Okay, negative 2x plus 5. So the question specifically says graph by using y-intercept and the slope. Okay, y-intercept and the slope. That means the y-intercept is at 5, b equals 5. So you go to 5, you locate that, and x, negative 2x gives you the slope m. So you go down by 2 and over 1. So you will not get any negative number. So you go down by 2 and over 1. So you get this point. So that's it. That's how you graph it. But some of you found the x-intercept by plugging y equals 0 and try to graph that point. So that's wrong. Okay. So you are asked to find b and m graph by using them. Okay. That's why you get that problem wrong in chapter 5. I'm talking from chapter 5 on graphing chapter 5. So I checked what you did. Some of you did. But the question says identify the b, which is the y-intercept, then use the slope to graph the function. You will not get a decimal. When you do that, you will not get a decimal. So this point is x0, y5. This point is 1, 3. So there is no decimal. Okay? I think that's what Norma is asking. Sorry, guys. I'm trying to explain some misunderstanding. So if you find the x-intercept, so if you plug in y equals 0 here, 0 equals negative 2x plus 5. So when you solve, x becomes 2.5. So yes, that the x-intercept is 2.5, but you are not asked to find the x-intercept. Just the y-intercept and the slope. Let's come back to what we are doing now. Okay, let's come back to what we are doing now. So if you input 2 points, it will automatically graph it for you. So or just look at how the problems are done in the book. So usually, if you don't know exactly what is, if you don't know exactly why you get the problem wrong, but technically you are right. So when you put 2.5, but the book specifically says use this and this. That's why it mark you wrong. So what you can do is just look at some examples they do in the book, and you can follow the same procedure. Okay. Okay, now give me the y value at x negative 1, 0, and 1. Anyone? Anyone who evaluated this function? Write on the chat. It's okay. Okay, guys, type your answers. What is f of negative 1? What is f of 0? And what is f of 1? Try to use your calculator. It's very important. If you know how to evaluate those numbers, it will be easy. 1 by f of negative 1. So if you plug in negative 1, f of negative 1 will be 2 times 1 over to the power of negative 1. So negative exponents usually flip the number. So if you have 1 over 2, it becomes 2. If you have 2, it becomes 1 over 2. So this is 2 times 2, which is 4. Or use your calculator. Just plug in the calculator. So f of 0, 2 times 1 over to the power of 0. Any number to the power of 0 is 1. So it is 2 times 1, which is 2. And f of 1 is 2 times 1 over to the power of 1. And 1 over to the power of 1 is 1 over 2, which is half. So it is 2 times 1 over 2. Half of 2 is 1. So we have 4, 2, 1. So at negative 4, it is 4. Sorry, at negative 1, it is 4. 1, 2, 3, 4. At 0, it is 2. At 1, it is 1. So you can clearly see this function is going this way. Any question on this example? Graphing. Any question on graphing? So at negative 1, it's 4. So we have a negative 1 is 4. So you go to negative 1. Let me put a different color. So at negative 1, it is 4. So you go to negative 1, it is 4. 1, 2, 3, 4. At 0, it is 2. So at 0, it is 2 here. At 1, it is 1. That's why we have this graph. Okay. So I mean, you don't have to remember the properties of exponent. If you just put that number in the calculator, it will give you those answers: 4, 2, and 1. Okay. Just all you have to do is just evaluate the expression. And I think in your in my MATLAB there is a graphing tool. So try to practice on that graphing tool. So the graphing tool will give you, if you give it 2 points, it will automatically graph the function, I think. Okay, now I have one more application problem. So I'll give you 5 or 6 minutes to work on the application problem. Then we'll talk about it at the end, and that'll be the end of the lesson. So application problem here. Let's the population of a certain city or country is represented in a function pt, where t is time in years, is 32 times 1.047 the power of t. Yeah, with the numbers are picked randomly, negative 1, 0, and 1. So usually we pick numbers around 0. Negative 1, 0, and 1. Yeah. Usually the common numbers we use is 1 and 0, because exponents are easy with 1 and 0. Any number to the power of 0 is 1, and any number to the power of 1 is the number itself. So for that reason, usually we choose 0 and 1, and we include negative 1 to see the behavior of the graph around 0. Okay. Now, let's the formula of PT represent 32 times 1.047 the power of P. Represent the total population in thousands. Okay, so this is in thousand. Whatever you get, you multiply by 1,000. Of a small town in New York. 3 years after the last census. What is the population of this town 5 years after the last census? census. So we are looking for a population of small town. So the formula is given. All you have to do is plug in t equals 5 and evaluate the expression. So I want everyone to do this because I want to know if you guys know how to evaluate by using calculators and using your calculator. If you don't know how to do this, please let me know. Or if you don't have calculator, just open calculator online, type graphing calculator or scientific calculator and type this formula and make t equals 5. So this is basically what you do. T equals 32, and we are looking for T5 equals 32, 1.075. After you find this, multiply by 1000 to find the population. The population. So you multiply whatever result you get here by 1000. Okay. So let me give you 5 minutes on this one. I don't think it takes 5 minutes, but once you finish, type your answer on the chat. You type your answers, guys. Okay, good, good. So you have to, normally your number is good, but you have to multiply by 1000. Don't forget. That's P5. Let me see. So you got 4. Excellent, Abby. That's the correct answer. So finally, the population is 40,261. Excellent. So we have 40 point. So we can round it to 1000 place because we are going to multiply by 1000. So to find the population, you have in 1000. That means you have to multiply by 1000. So it is 40,261. Okay, so this concludes our lesson. If you have any question, please let me know. Otherwise, I'll give you the remaining 20, 25 minutes, 20, 22 minutes, I think 20, 21 minutes to work on 12.1. You can finish it in class, okay? So use your time, finish the assignment. So don't wait until the deadline. So next week will be spring break. So use that time to adjust your schedule and your time. And we'll meet after spring break. Um, I hope most of you are doing good. So I was checking grades last Tuesday. So some of you are missing some assignments here and there. So the assignments will not affect the grade significantly compared to the tests. So the exams are very important, and also the final exam. So the final exam is 30%. So at the end, I'll give you time to work for the final exam. Just practice, and I will give you a study guide for the final exam. After that, uh, if you missed a test or exam, or if you failed one of the exams, you can replace it by the final exam. So if you do well on the final exam, one of the exams will be replaced. Okay. Yep. So that's the lesson for today. If you have any question, type or speak up. Otherwise, you can go to my MATLAB, start working. You have two options. You can stay here, and if you want to go, you can go and log out. And I'll see you guys after spring break. Bye. Thank you, Hugo. Oh, the videos, you can't find them? Oh, okay. I don't know. Okay, I will definitely send them to Canvas, post them on Canvas. So I'll create some kind of folder, and I'll name it like live video or something like that. So you will find it on Canvas. Okay, I thought you guys access it from the big blue button. When I log into big blue button, I can see them. So that's why I thought you can access. Okay, I will definitely do that. Graphing, yes, go ahead, Jasmine. What is the question? Did you send me an email? I saw your email, but it was embedded from previous emails. Sometimes when you respond to previous emails, uh, it just go below, and I see like it feels like old emails. That's why I'm missing some emails. So what is your question? Let me answer some of. Okay, so it says -4 x minus 7. Okay, -4 x minus 7. So y equals -4 x minus 7. So this is the slope because the equation is mx plus b. So the m is the slope. You can see m is -4. So you go down by 4 and over 1. So technically -4 is -4 over 1. And b is -7, which is. So you can, for example, if you when you drew the, you start from -7 somewhere here. 1, 2, 3, 4, 5, 6, 7, somewhere here. Now, if you go down by 4, you may go out of. So you have two options to graph functions like this. So you either go down by 4 and over 1, or up by 4 to the left by 1. So it's like this is the same as 4 over -1. So sometimes if you are out of range, students get confused. But you can change the fraction into 4, which is positive going up, and -1, that means to the left. So I can do, so I have 7 here. The first point is -7. So I can go up by 4. 1, 2, 3, 4. and to the left by 1. You can even graph by using this, or go down by 4 and over 1. So the same, you go down by 4, you have space, and you move over 1. So somewhere. Okay, so that's it. I don't know how it is in your my MATLAB. If it is out of range, for example, if the range, I mean, if the range is from -10 up to 10, if it goes out of range, what you can do is you go up 4 and to the left. So because these two fractions are the same, -4 over 1 and 4 over -1 are the same. And yeah, this is okay. Yeah, you have to practice. If you practice, you'll get it. Okay. Find the slope if existence of a line containing pair this and this. Okay, I'll do it very quickly. So I'll give you the formula first. If I give you the formula, you will understand. So 2 points are given, which is -9 and -6. And we have -12 and -10. So let's say this is point 1, okay? Point 1, that means this is x1, y1. Let's say this is point 2, this is x2, and this is y2. So this is the formula for the slope. M equals y2 minus y1 over x2 minus x1. Rate of change of y, change in y over change in x. That's what basically what slope is. So y2 is this one, is -10, minus y1 is -6, divided by x2 -12 minus -9. So this changes into addition. So -10 plus 6, -12 plus 9. -10 plus 6 is -4. -12 plus 9 is -3. 6. So it is 4 over 3. Okay, just plug in numbers.